Good day. This is Friday, the 8th of January. Just now that I'm back in the groove, we will be having live classes today, so I'll be sending out messages. But what I go through today, this is basically going to kind of finish our study of synthetic division. So we're going to look at some more advanced problems today using synthetic division. Similar format to yesterday, 4 questions and 4 examples. So just a reminder too, under number 4, the homework assignment is due on Monday the 11th that I posted yesterday. And Tuesday the 12th, there will be an Edge Elastic assessment. So I hope to get those problems to you to review. We'll go over those Monday the 11th. But I will try to make sure you can have them ahead of time to get started. The assessment, of course, is 10 multiple choice questions. I'm saying a little bit, either 5 or 6, half of it, a little bit more than half of it's going to be on division of polynomials. And then the rest of it will be on equation solving, rational equations, factor out the greatest common factor, stuff we did earlier in the unit. So we're going to start today with the same problem we did yesterday. Okay, where we're going to solve this problem. Yesterday we did it through long division, and today we're going to do it through synthetic division. Okay, so when you're setting this up, just to give you a head start, your excluded value should be -3. We're going to do some problems today with 2 excluded values. We'll look at those in examples 3 and 4. And then your dividend is 1x cubed. And then you skip all the way to 27. So you need a 0 for x squared and a 0 for x. Okay. So complete this, and I'll be back to go over it. So welcome back. This is what we should be getting after we set up the coefficients. Bring down the 1. Okay, and arithmetic's pretty easy. Times -3 is -3, and then just add vertically. -3 times -3 is +9. Added to 0 is 9. And on this one, remember, the answer should be x squared minus 3x plus 9, which is the same from yesterday. So it's 1x squared, -3x, and that's your constant. So that's our quotient. So today we're going to start to look at some problems. Well, we actually did look at some yesterday with remainders. Okay, so next thing I want you to do is just turn to example 1. And what we're going to do, dividing polynomials using synthetic division. Okay. The ones yesterday didn't have any remainders, but if we come across some, definitely come across some in the review. So here, in this problem, this is where we're going to focus on the coefficient today, the divisor, which is 2. Okay. So our excluded value, we set the divisor equal to 0 and solve for x. So that means x is -2. That goes inside our box. Okay, and we still have to take into account 2 at the very end as well. So it's 2x cubed, and then we have 0x squared, so you need a placeholder here. And then -18 is okay, and +7. So you're going to make sure you know where the placeholders are. And then just complete the process, bring down the 2. 2 times -2 is -4. 0 added to -4 is -4. -4 times -2 is 8. -18 plus 8 is -10. So we get a remainder here. This is good. And -10 times -2 is 20. So you get a remainder of 27. Okay. But I'm going to point out the very important rule here. Okay. Write the quotient using the coefficients. Your 4 remaining coefficients, this is from the example we did yesterday. You always want to divide those coefficients by the leading coefficient and the divisor. Okay, which yesterday it was 1, but in today's first example, it's 2. Okay, and then again, we never divide the remainder by that leading coefficient. So you always want to leave the remainder alone. Okay. So you're dividing a cubic by a binomial, 2x plus 4 is in the first degree. So 2 should be the coefficient for x squared. But it's not technically 2. You got to divide 2 by 2. And you got to divide -4 by 2. And you got to divide -10 by 2. You don't touch the constant, the remainder. Okay. So 2 divided by 2 is 1x squared. -4 divided by 2 is -2x. -10 divided by 2 is -5, with the remainder of 27. So we write the remainder like this. It's 27 over 2x plus 4. Okay? Because you got to think of it like this. When you're doing the long division, we would always take 2x cubed and divide it by 2x and end up with x squared. That's what this term is. But we got to account for it through synthetic division by dividing the coefficients by the leading coefficient in the divisor. Okay. So that's a rule you got to remember. Okay. So when you're doing example 2, you're going to divide those remaining coefficients by 3. Okay, so be back to go over this. Let's just try to get it set up first. So when we get this set up, okay, your excluded value is +3, because 9 divided by 3 is 3. And then just align the coefficients: 3, 12, 0. Okay, 0 again, because you're going from x squared to a constant. So you need a placeholder for the linear term. And -11. Just going to check something here. Okay, so that's -11. So when we go through with it, I'm just going to take you through this right now. 3, and 3 times 3 is 9. Over 9 is 21. And 21 times 3 is 63. Add 0, you get 63. And then 63 times 3, you get a big remainder here. You get 189 when you multiply those two values. Added to -11 is 178. And then we go back and apply the rule. We're going to divide everything by 3. And why 3? Because the 3 in here. So we end up with 1x squared. 21 divided by 3 is 7, so that's 7x. 63 over 3 is 21. Remainder of 178. So we say 178 over 3x minus 9. Okay? So what I want you to do next, I'll pause this and we'll go over these. Complete problems 1 and 2 and the assigned problems. So I'll be back to go over these. Hey, welcome back. I prepared most of this because I want to get to the division and fixing this up. So, first of all, in question one, that -4 in the excluded value comes from 4x plus 16, we set equal to 0. So 4x is -16, which means 1x is -4. So that's where that comes from. Now, there are no placeholders in the dividend. It's simply 4, 12, -16, and -9. Drop the 4 times -4 is -16. Then -16 added to 12 is -4. -4 times -4 is 16. Add these vertically, we get 0. And then, of course, 0 times anything is 0. So we have a remainder of -9, but you can't forget to account for the 4 in the divisor. All right, so you have to divide all of these by 4, except the remainder. This is your remainder. So we got 1x squared minus 1x. You don't even have to put the plus 0. So the remainder is -9 over 4x plus 16. So we leave the 0 out of our answer. So it's -9. Okay, so to be clear about something about the remainder, we never use a minus sign here. It's always plus what the remainder is. So it's always plus a positive or a negative. In this case, it's a negative. Okay. And I believe question 2 had a placeholder. Yes. So your excluded value, first of all, that -3. So 3x is -9. 1x is -3. Simple. That goes here. Then drop the 3 times -3 is -9. Add vertically. We get -18 times -3 is 54. Add it to 0 is 54. And the numbers do get kind of large here. 54 times -3 is -162. And then -162 added to 14 is -148. So your remainder is -148. And then for your quadratic term, your linear term, and your constant, we have to divide by 3. And why is that? That is because of the 3x in the denominator. So it's 1x squared minus 6x. 54 divided by 3 is 18. Remainder is a -148 over 3x plus 9. Okay? So if we work our way back to examples 3 and 4, okay, I came up with some very usual combinations here. So these are type of problems you can either do through long division. Well, you can do all of these through long division or synthetic division. But when your divisor has an excluded value or has more than one excluded value, you can use synthetic division. So what do we mean here? We mean that this particular problem is going to have 2 excluded values. All right, so we're not even going to put one in there yet because it's going to come from x squared minus 7x plus 12. Okay, but you notice in this 4th degree, in your dividend, which is in the 4th degree, you got 5 coefficients. So you got 1 for x to the 4th power, -4 for -4x cubed, negative 27x squared, 162, negative 216. Now the question is, where do we find the excluded values? Okay. It's a little bit complicated. I'm going to do this separately. You got a choice here of starting with one or the other. So the rule is when you find your excluded value, you set the denominator equal to 0 and you solve for x. Okay, so in this problem, okay, we're going to solve this through factoring. Factors of 12 that add to negative 7 are negative 4 and negative 3. So you got two excluded values here. You got a 4 and you have a 3. So we have to decompose the fourth degree polynomial down to a second degree polynomial by using both of these. Okay, so which one we start with doesn't really matter. So I'm going to start with the 4. So we're going to start with 4 and 3. I'm going to erase this. That's how you find it. So I set these up so you can easily factor these. You could actually do them using imaginaries too. We just don't have enough time. Maybe I'll throw that in during the review just to show you. But it works really good with imaginaries. So we start with the 1. Okay, so the process is easy. So 4, 0, 0, negative 27. Now the numbers get a little bit big. Negative 27 times 4 is negative 108. Negative 108 plus 162 is positive 54. Here's the beauty here. 54 times 4 is 216. So it comes out to 0. Okay. So you've decomposed this down to a third degree polynomial. X cubed minus 27x plus 54. We're now going to decompose it a second time using the 3. Remember, we're going to use 4 and 3. It doesn't matter which order you use them in. And then we just do it a second time. 1 times 3 is 3. 3 times 3 is 9. Added to negative 27 is negative 18. And negative 18 times 3 is 54. Well, it's negative 54. So now you get a quadratic because you got 4 terms. The last term being, the last coefficient, I mean, being the remainder. So the quotient is 1x squared plus 3x minus 18. Okay? So the key here is just getting the two excluded values. So before we start the next question, we're just going to find the excluded values. So the next question, we'll come back and look at this. But when we set the denominator equal to 0, factors of negative 6 to add to negative 1 is minus 3 and plus 2. So 3 and negative 2 are your excluded values that you're going to use. Okay? So we'll make that note and then we'll come back and finish this up. Okay, welcome back. So as you can see, I didn't do much. I think this is one of those topics you got to kind of talk as you go, but could be wrong. I would approach it that way with kids in the classroom, and then if I was very confident with the kids, I just have it posted. It's just, you got to get a feel for that with your audience. what's going on here. Hold on. Okay, figured out the issue. So this process has to be completed twice. So we said the excluded values were 3 and -2. So one thing other to note, one thing to note about the dividend as well is that we go from x to the 4th power to -19x squared. So you need a placeholder 0 for x to the 3rd power. You go 1, then times 3 is 3, 3 times 3 is 9, added to -19 is -10, and then -10 times 3 is -30, added to 6 is -24, and then -24 times 3 is 72, -72. So you get a remainder of 0. And then you got to do it a second time. Doesn't matter what we just start with. Obviously, the second one has to be the opposite. Has to be the one you haven't used. So 1 times -2 is -2. And this is added to 3 is 1. 1 times -2 is -2. That's -12. Times -2 is 24. So you get 0. Let's write our quotient here. Okay, so it's 1x squared plus 1x minus 12 with the remainder of 0. Okay. So in the transition, do problems 3 and 4 on the assigned problems. Very similar to this. And I'll be back. Okay, so on number 3, to get your excluded values, you did 2 factors of multiply to -10 and add to -3. And 4 is a little bit different here. Let's see if you can figure out 4. We'll talk about it. Okay, welcome back. So just to go over questions 3 and 4, the answer to question 3 is x squared minus 4. So let's just take you through it. So when we look at the denominator, the divisor, denominator means the same thing. Your excluded values are 5 and -2. Okay, because your factors of -10 that add to -3 are -5 and +2. So when you start the process of synthetic division, it does not matter if you start with 5 or -2. You have no placeholders here. So the arithmetic is pretty self-explanatory. I did 1 times 5 is 5, add down to get 2, times 5 is 10, add down to get -4, times 5 is -20, add down to get -8, times 5 is -40, add down to get 0. So here in the green, I add the second excluded value of -2, bring down the 1, times -2 is -2, and these cancel. So you're going to end up with 0x, as you can see here. Excuse me. And then 0 times -2 is 0. Add down, we get -4. And then you have no remainder, because -4 times -2 is 8. And the potential column for remainders cancels. So we want to write our answer here as x squared minus 4. They take up the 0x. Now, number 4 is a little tricky. First of all, if we scroll down a little bit in your dividend, you have 2 placeholders. You got 1x to the 4th power, skips over x cubed, so this is a 0x cubed, -13x squared, 0x, and 36. Now your factors of -9 and your divisor when you're finding the excluded values, I factored the factors of -9 to add to 0 or 3 and -3. You can also do this. You don't have to factor this because you can simply on this one, if we want to just review, you can say x squared equals 9, x equals plus or minus the square root of 9, which is your plus or minus 3. Okay. So either method, you're going to have two excluded values. So I started with the 3. Okay, bring down the 1 times 3 is 3. Add down in the second column, we get 3. Times 3 is 9. Add down, we get -4. Times 3 is -12. Add down, we get -12. Times 3 is -36. Then add down, and we get 0. And then do it a second time using -3. Bring down the 1. 1 times -3 is -3. Add down, we get 0. Times -3 is 0. Add down, you get -4. -4 times -3 is 12. Add down, and we get 0. So we end up with 1x squared plus 0x minus 4, which is equals x squared minus 4. Okay. So I will have the practice problems out to you, and we will go over them on Monday. I'm going to post the assignment till Monday, but I will send out the Word document to you. So in the meantime, have a great day. Keep the peace. Thank you.